Hello, you're welcome to my channel. Now right here in this video, we want to find a way how to differentiate this polynomial function. We have y equals to a cosine x plus b sine x. So we have to find the derivative of this function, which is a function in terms of x. We have to find the derivative of the function with respect to x. Alright, we will take the first order derivative, and as well we'll go ahead and take the second order derivative. Don't worry, you will know what that looks like. Okay, first of all, let's differentiate this with respect to x. Now, when we differentiate a function of x, we use this notation y. We can write the derivative as y complement, like that. We just put a little, slash, like raised to power 1, but it's not really straight. We put it like that, y prime, which is the same thing as saying dy dx. Alright? So we go ahead and differentiate this. This is a constant, and these are constants. A and B are constants. Cosine x and sine x are the sine function of x. Okay, and I want you to know that for I believe you know already, the derivative of the sum, the sum of the derivative, so you just differentiate this and differentiate this. And again, when you're differentiating a constant, a product of a constant and a function of the independent variable, you just assume the constant to just be like that, alright? Like this, for example, you just put here a, the derivative with respect to x of cosine x, like that, plus b, the derivative with respect to x of sine x, like this, alright? You know about your product rule, where if you have the product of two functions of x, but in this case it's not so. Here we are having a constant, and here we are having the function of x. It's different from the u and v, where you have u the v plus v the u. This one is a constant and a function. It's not the function and the function situation. Okay, so we just go ahead and differentiate cosine x and differentiate sine x and sum them up, and we are done with your constants a and b. So from here we just have, well, this is a right here. Now the derivative of cosine x with respect to x is giving us negative sine x. So we just put it like this, negative sine x. Again, the derivative of sine x with respect to x is giving us cosine x. Remember, this is a constant, we just put it plus b like that, and we put right here cosine x. Like this. This is just the derivative of y with respect to x, of which you can still write it as your y prime, like that, right? So this, I can call this the first order derivative. That means you've differentiated the function, alright? That's the first order derivative, is the ordinary differential equation we know. This is it. Again, you can go ahead and differentiate this function, the already differentiated function. Differentiate the function, you have y prime, which is the differential coefficient of y. You can go ahead and differentiate the first differentiation, the first derivative. You get the second order derivative. By saying so, I mean you differentiate y prime like this. This is y prime, you differentiate that again. Or better still, if you want to use this, you can say the derivative with respect to x. This is the differential coefficient of dy dx. And by saying so, you are going to get, if you want to expand this, you're going to get the square y over the x squared, like that. So any of these shows the second order derivative, which means you are differentiating the already differentiated stuff, alright? So you differentiate this function, you get this. Now you differentiate this to get the second order derivative. So I'm going to make use of only this right here. So I'm going to clean these other ones because they are all the same thing. Okay, so what I had here, I can still write it as this. Okay, the bracket I put, I can just bring it up. And here we just have, this is the function we differentiated. So we differentiate this and this the second time. Alright, remember that this is your constant. In this case, it's now negative a. So I'm going to put negative a as a constant. I'm going to multiply by a derivative with respect to x of sine x. And again, plus this is still a constant. Alright, we have b and the derivative with respect to x of cosine x, like that. And now the derivative of sine x with respect to x, this is a, of sine x with respect to x is giving us cosine x. So we have negative a times cosine x. And the derivative of cosine x with respect to x is giving us negative sine x. So we have here negative. This is positive, so you just get the negative sine x. This is your y prime prime is equals to that. Well, we are done. Alright, so we can just go ahead and you know, take a negative since that's common, and we just have a cosine x plus b sine x. Well, this is y prime prime. All right, we are done like this. But well, look up right here. This is y equals to a cosine x plus b sine x, and here we just have a cosine x plus b sine x. What do we say? Well, we can just say since a cosine x plus b sine x is equals to y, therefore y complement complement is equals to y. Oh, wow, that's a very nice relation. Negative of y, sorry, negative of y. But well, like this is still okay, right? Great. But you know, as a nice student, it is always pretty much good to put your positive number in front. But in this case, you don't have a choice to put the positive number in front because the two numbers are negative. Okay, but well, you are done. But what if you just say to always get a positive number in front? I will tell you, let's y complement complement be equal to, let's just bring in something. Let's bring in 1. 1 minus a cosine x plus b sine x, like this. Well, here we have a positive number in front, but this is not the same thing as our solution. So what do we do? Well, as if like that, we just take away the 1. But this one is just for fun, alright? Okay, but this is your second order derivative of y with respect to x. Okay, thanks for watching. Please subscribe to this channel.